Hello, hello, hello. A warm welcome to all of you for joining in our the second webinar on platform engineering that we are doing. I am Atul and I work as a senior developer advocate at InfraCloud. I am a CNCF ambassador. Outside of work, I am a food and travel blogger and also your host for this webinar. And as I said earlier as well, being a host is something that I enjoy because whatever you see on your screens are something that I control. So let me use that powers and bring up the speakers for today, as I'm not alone here. So let me bring in Kurt from Lock Labs, and let me also bring to stage Vishal from InfraCloud. Welcome, Kurt. Welcome, Vishal.
Thank you.
So both Kurt and Vishal are stalwarts in their game, in their field, and I think it's best for them to introduce themselves. So, Kurt, why don't you go ahead and introduce yourself to our audience?
Sure. My name is Kurt Medell. I'm a senior solution architect at Loft Labs. As you can see from my hat, maybe you guessed, I'm from the state of Virginia, in the United States. I've been in the CI/CD space for quite a while. Before that, I was an engineer at Capital One and a consultant before that. I'm really happy to be here, and thanks for having me.
Thanks a lot, Kurt. Vishal, would you like to go next?
Sure. Thanks, Atul. Great to have you, Kurt, as well on the webinar. My name is Vishal. I'm founder and CEO of InfraCloud. I have been a programmer early stages of my career, and then got interested in systems. Back in the days of Chef, Puppet, and Capistrano and whatnot. One thing led to other, and Docker and Kubernetes and Mesos, and we are here. I think last few years I've been focused on open source technologies around the cloud native space and helping enterprises adopt these technologies effectively and scale from there.
Interesting. Thank you so much, Vishal, for that interesting introduction. So, like Kurt said, he's joining in from Virginia. We have Vishal who is joining from Pune in India, and I'm joining from Hyderabad in India. So, I would love to know where you guys are joining in from. So, just drop in the comments where are you joining in so that we know which part of the world you are joining in from. So, with that, I would like to tell you that we have been doing the series of platform engineering webinars, and this is the second one. And in case you are joining in this webinar for the first time, you can watch our previous videos, previous webinars that we have done. So you can scan this QR code, and it will take you to the playlist page that we have, and you can watch the previous webinars that we have conducted. Having said that, this is not a course. So watching the previous webinar is not a prerequisite to this webinar. So if you are here for the first time, do know that each of these webinars are unique in themselves. So irrespective of whether you have seen them or not, we can can just go ahead and continue watching this webinar. So before I get started, we would be taking in questions. So if you have any questions, clarifications needed during the course of the session, you can ask our experts and drop them in the comments, and we would be taking questions at different intervals during the webinar as well. So with that out of the way, I think we can get started with today's webinar, where we are going to talk about harnessing efficiencies using vCluster. But before that, the larger idea over here that we are going to discuss is about platform engineering and how it all basically started. So back in the day, the whole idea about developing applications was letting your developers focus more on building the logic of your applications. However, as time passed, what happened was we all started shifting left, and that one thing led to other, and suddenly we expect our developers to know everything from setting up the infrastructure. You want them to know how Terraform modules work. You want them to know about networking, service mesh, and a whole lot of things. And what this has done is that it is in a way affecting their productivity as well. And that is where the whole idea or the paradigm of platform engineering came in, where the essence was to let our developers focus on building the application, and everything else would be provided to them through platforms, through internal developer portals, and everything along with that. So uh, platforms have been there for quite some time now, and they have been helping developers to do a lot of tasks, to simplify and make a lot of processes in their daily work a lot more easier. So, things like day zero operations, when you have a new developer joining in your team, essentially you would have a senior developer helping them, set up the environment, set up the packages, libraries, dependencies, everything that is needed to get them started. But with platforms, you can set up templates, you can set up golden paths where new developers in your team can just follow it as a guide and achieve whatever is required with minimal intervention from anyone. And also, this makes the entire process quite fast. So this was typically a day zero scenario, but platforms today support a lot more complex scenarios as well, and we would definitely be looking at one of those scenarios today in this webinar. So to know more about what platforms are and what platform engineering is, I would recommend that you go through the CNCF platforms white paper, which was published by the Tag App Delivery Group a few months back. It is a good place for you to start your platform engineering journey as well. So over the past few months, we at InfraCloud have been uh, doing a lot of work around platform engineering internally with our clients, and as well as contributing to the Tag App Delivery Group and in general the entire community as well. So as part of that, what we have done is we have come up with the platform engineering reference architecture ebook, and the whole idea about this ebook was to help teams start their platform journey, because we realized based on our interactions with clients, with the community, that the starting point with on a platform engineering journey is not easily identified by a lot of teams, and we thought that this book would be made for them to help them get started. So what do you expect from this book? So there are a few things that we have included. We have provided with engineering blueprints. So anyone who is starting out, you can refer to these blueprints to chalk out your plan, chalk out the platform that you are building. We have also provided a lot of tool suggestions along the journey of this book, so the capabilities that your platform should provide and what are the various tools that you can use. And the book also features a lot of questionnaires that you can take. So you can go through those self-answering questionnaires and understand where you stand in your platform journey and what are the next steps that you have to take. So you can download this ebook that is available on our website. So you can just scan the QR code which is here, and this book is freely available for you to go through it and start your platform journey. Uh, while you will download the book, I would like to give you a couple of things that we have covered in this book. And one of the things that we have listed over here are the platform engineering capabilities. So every platform that you build should have certain capabilities, and we have put these capabilities into three buckets. So one is develop, the second is consume, and third one is discover. So if you see this image, we have listed everything in these three buckets. So if you look at develop, these are all the services that are required by developers to build a particular application. So things like templates, workload specifications, environments that we are going to talk today, these are essentially required for developers to build their application. When we move to the second aspect, which is consume, these are external services that are used by developers to build their application. So, things like databases, messaging queues, registry, a lot of identity and secret provisioning services. So these are essentially third-party services that are used by them to develop their applications. And lastly, we have listed some of the features under the discover categories, which basically helps them observe their application, or manage the application, get some visibility into it. So these are secondary services, but again essential in building the application. What we have also done is that we have provided a platform engineering capability map. So essentially, any platform that you build should have a certain set of capabilities for your developers to succeed, to be more efficient, and all your workflows to be more streamlined. There are 8 of these categories that we have mapped. So we have service templates, we have workload specifications, pipelines, environments, testing infrastructure, progressive delivery, and environments. So each of these capabilities are required for your platform to succeed. And in the ebook, we have provided suggestions, tool suggestions for each of these categories. So, you can take those tools and start building your platform. Today's webinar, we are focusing on environments, and that is where we would be talking about vClusters and virtual clusters. And this is the second webinar, as I said, where we are touching upon environments. And over the couple of next few months, we would be touching upon each of these capabilities and some tools associated with each of these. So we can get started with today's webinar around virtual clusters and vClusters, as I said. So a little bit backstory of how we reached over here. Me and Kurt were discussing some time back that uh, some few years ago, building applications or deploying applications was a tedious task. And in the early days, we relied a lot on virtual machines and bare metal solutions initially. But over the years, as the demand for agility, scalability, and flexibility started, we wanted some more, flexible solutions in place. So over the years, Kubernetes came to the party, if I can say so. So it became the default orchestration tool, and slowly and steadily, the next logical step over here was to look at how to make our applications more scalable and streamlined. And that is where virtual clusters emerged as the next step. And that is what we are going to discuss today. So, Kurt, why don't you start by simply explaining our audience, explaining our viewers what are virtual clusters?
Sure, I would love to. So, as you know, Kubernetes has just grown by leaps and bounds, and the workloads increase every month, and with that has brought more and more tenants. And so, multi-tenancy is a kind of a major issue with running Kubernetes clusters at scale. So, vClusters basically were created to solve the problem of multi-tenancy and as a balance between running multiple physical clusters and using namespaces for multi-tenancy, which we saw growing and growing, and there's lots of different problems. Basically, a virtual cluster is a fully functional CNCF certified Kubernetes cluster that runs as a pod in another Kubernetes cluster, a host cluster, in the namespace of that host cluster. It provides an efficient and flexible way to manage multi-tenant environments within a larger Kubernetes cluster. This enables more secure and more capable multi-tenant environments than using namespaces alone, and greatly reduces the costs of creating non-virtual, that is physical clusters for each tenant.
Yes, I think what you mentioned about multi-tenancy, that is quite an interesting concept, and that is where virtual clusters are essentially helpful in segregating the users and their namespaces and essentially their environments.
Yep.
Over to you, Vishal. How would you describe virtual clusters, or any particular feature or anything that you feel the audience should know about virtual clusters? Your take on this?
Sure. So I think in addition to what Kurt was saying, basically companies are running today either too many number of clusters across their development teams and software engineering organizations, and that kind of gets a little bit out of hand beyond a certain point in terms of cost, in terms of management, in terms of consistency and stuff like that, right? So I think virtual cluster kind of virtualizes the cluster. That's basically the fundamental kind of name gives the idea away. If you look at virtual machines, let's think of the same thing when now applied to Kubernetes clusters. And I think as more and more teams start adopting clusters, I think that was almost like a needed solution, because you can't keep running clusters on the actual cloud or whatever other infrastructure you're running. There are cost implications, there are other implications, there are obviously tenancy implications and stuff like that.
Absolutely. I think you summed it up perfectly, saying that virtual clusters are basically virtual clusters. The name gives it all. So I think fundamentally, both of you have given our audience an understanding of what virtual clusters are, and why are they necessary, and what are the other benefits that they bring into the table. Now, obviously, this is not a deep dive course in virtual clusters, so we won't be going into the very minute details of it. But having understood them at a very basic fundamental level, what we also realize is that this is helping improve the developer efficiency in a way. It is helping our developers be more productive as well. So now, whenever we talk about productivity and efficiency, I think there are a lot of metrics that we track. We want to see how implementing virtual clusters or environments for our developers is helping them. Is it reducing the time somewhere, or is it making things faster? It is reducing bugs, and a lot of other things are there. So, Kurt, over to you. Can you share some insights or instances into how these virtual clusters provide some tangible benefits?
Sure. I don't have any real metrics to share today, but using a vCluster spin up really fast. We're talking seconds compared to physical clusters. Some physical clusters, EKS, for example, can take 30 minutes or longer. So let alone of the expense of the running the physical clusters themselves, it's the speed that increases the productivity of developers by not having to wait for the resources they need to get their job done. That's just one simple example.
Yep, I think speed is the name of the game. I think that's the reason that phrase is there, because irrespective of what part of the world we are in or what industry we are in, I think everyone wants to do things, build things faster, and like you rightly pointed out, speed is what actually essentially helps. Vishal, what is your perspective towards any interesting metrics or numbers that you can share about virtual clusters?
Sure. Again, I don't have metrics and numbers, I would say, and speed is absolutely a great point because you want things to, from developers' point of view, beyond the development, you want everything else to be as fast as it can be. I think there is another psychological factor of the teams that if they have to spin up an entire EKS cluster or any Kubernetes managed cluster for testing this thing, there would be resistance from a multiple point of view, like resistance in terms of cost because you're going to spend some money, resistance in terms of time it takes to spin up something and test it out and tear it down, kind of gracefully because you can't leave it open. So teams might take shortcuts. They might take, what, let me test this service in a different way here in my local machine or wherever, and then put in dev or QA or staging at some point in time. So you're delaying finding the bugs. The more you're delaying finding the bugs, the more cost you're incurring in terms of the software engineering cycles, basically, right? So if you're able to spin up a cluster as quickly as possible on your machine or even in a shared cluster, I think that far reduces the amount of time you would spend finding the bugs later and later in the life cycle. So that to me is very intangible in a way. But if you really put metrics in terms of how fast you could find bugs for a team before vCluster or something like vCluster versus after vCluster, I'm sure we could see that difference between the velocity or speed of finding things and moving things faster, I would say.
Absolutely. I think again, as they say, time is money. Speed is the name of the game. I'm just getting these sentences which are perfectly fitting for fitting for the developer productivity aspects that we considered. So and I think you rightly mentioned that the whole idea of ensuring that your bugs are actually identified earlier in the stage so that your costs are less, your technical debt also is affected positively, so that it doesn't affect you much later in the stage as well. And I think we all know that there has been a good adoption of virtual clusters, again for the benefits that Kurt earlier mentioned as well, looking at things like speed, spinning things faster, getting the environments ready quickly. So essentially, developers today don't have to waste a lot of time in getting things there. Whether you talk about testing, QA, or even the developer environment, all they have to do is a couple of clicks, and within a few seconds we have the entire system in place. There is one change that we have observed for quite some time, and I think I would divert the discussion towards that thing. And what we are seeing today is that a lot of enterprises today are choosing a multi cloud setup, sort of, if I can say, if that's the right word. So you see a lot of their applications or services being scattered on different clouds, some on-prem, so basically they are everywhere. It's everywhere. And my question to you, Kurt and Vishal, both of you, is in this age, where you talk about hybrid models and where you talk about multi-clouds, multi-cluster setups, what are the challenges or opportunities if you see with respect to virtual clusters?
Sure. One of the opportunities I see with virtual clusters and vClusters specifically is that it makes it really easy to run the exact same distributions of Kubernetes across multiple environments, whether it's EKS on AWS or bare metal on private cloud. Furthermore, I am on the sales side, but vCluster Pro actually has a feature that allows you to run the vCluster control planes on different, less expensive clusters and run the workloads for those control planes on more expensive nodes. So, for example, you could run the vCluster control plane on an EKS spot instance node, but then actually run the workloads for that vCluster on a GKE node with GPUs for like maybe an AI workload. So that just really kind of expands the ability for hybrid cloud and multi-cloud with Kubernetes that just wasn't possible before in the past.
Vishal, what do you have to add to this?
So in terms of, I think, opportunities, definitely consistency across, where you're running is a big one, I would say. I would probably also look at challenges. I think if we were doing, I don't know, let's say 100 clusters without vCluster, and now we are doing, let's say, 1,000 clusters with vCluster, it might be good to look at as organization. Can we have some standard templates? You don't want everybody to be again, customizing to, their own whims and fancies, so to speak, beyond a certain point, right? You're basically increasing the sprawl, and every sprawl comes with its own challenges of drift across multiple versions of clusters, right? So I think teams should definitely adopt some sort of templating across these thousands of clusters, virtual clusters that will come up. The second, obviously, is the whole point today probably is to move to a virtual cluster is to kind of to an extent save on cost. You don't want to spend on the actual cluster. You kind of want to bin pack as much as possible. So if you don't have good policies around shutting down those virtual clusters, if you're keeping them around, you might actually end up into a situation where you are probably now paying more, with using vCluster as well. So I think there needs to be some mindful policies and governance and some templatization in place for people to really effectively use this. Is some of the opportunity or rather challenges, I would say, in a multi-cloud and enterprise kind of setup.
So if I have to, sum it up in two words, I think the two key words that I have to take from what Kurt and you said, one is definitely consistency that it brings when you are dealing at different areas, different environments. And second thing that we should focus on is templating. So both of these go with hand in hand with each other, and that is what it brings to the entire setup. We would also be talking about, or rather focusing more on the templating and consistency stuff in the next webinar that we are planning. So, make sure to stick around for the next webinar that we're coming up with, where, the focus would be again around consistency and templating. So I think to quickly sum it up, like all of us, we do want to see things in action. Enough of talking. We have spent about 30 minutes. We have been talking about platform engineering, DevOps, how we got here. We spoke about virtual clusters. We have some understanding. If we all started the webinar with no idea about virtual clusters, I'm sure we are at a level 10 on 100 or maybe 20 on 100. So we have some understanding about virtual clusters now. We also looked at the benefits that bring in terms of speed and agility as well as flexibility. And lastly, we looked at the challenges and opportunities, especially when you look at the entire scenario from a multi-cloud and a hybrid setup. So, like I said, we would now be going into the meat of the webinar, where we would be deep diving into what vClusters are and look at how they actually work in reality. So I will throw the stage open to Kurt and let him cast his magic spell on this webinar and show you what vClusters are and what they do, how they help us. So Kurt, the stage is all yours.
Excellent. Thank you so much. Do you mind going to the next slide, please? I'm going to start just with, we already kind of explained at a very high level what a vCluster is, but I wanted to dive a little bit into the architecture, have a few slides to explain some of the benefits of vClusters, and then going to do a quick demo. Again, at a high level, a vCluster is a pod, actually stateful set to be more specific, that runs in a namespace of the host cluster. The core idea of vCluster is to provision isolated control planes that run on top of a real Kubernetes cluster, when working with the vCluster's API server, resources first only exist in the vCluster. However, some low-level Kubernetes resources need to be synchronized to the underlying cluster. As you can see in the diagram, pod 1 is being synced from the virtual namespace of the vCluster into the namespace of the host cluster, at which point the host cluster will schedule it on a real physical node. We can't create memory and CPU out of ether, so we still need actual hardware somewhere to run these things on, right? Even if they're EC2 instances. So anyways, generally all Kubernetes resource objects that you create use the vCluster API server, which is another benefit because you're not hitting the host API server to do things with Kubernetes in that host cluster. You're not going to overload the API server of the host. You're going to have a vCluster for all your workloads and have dedicated API servers for each vCluster. And then finally, that applies in particular to the highest levels, such as deployment, stateful sets, CRDs. Most of these things remain virtual forever in the virtual cluster and put no load whatsoever on the host cluster. However, there is a sync configuration where you can sync whatever you need, and we'll get into that. If you want to go to the next slide. So again, back to multi-tenancy real quick. I don't want to spend a lot of time here, but basically there's kind of three main solutions today: separate clusters, namespaces, and kind of the newer solution, although it's been around for a few years now, is vClusters. Cost savings. Multiple clusters very expensive. Namespaces are very cheap. vCluster somewhere in the middle. Flexible multi-tenancy. Very difficult to share, to give cluster admin access to everyone that needs it or wants it with physical clusters. vCluster makes that a piece of cake. Namespaces, you don't really ever get, all the capabilities that you need in a full cluster. And finally, tenant autonomy. Tenant isolation, obviously the strongest with separate clusters, but vClusters and the different configurations that are available for isolated mode and such are way more isolated than namespace. And that's one reason you see less and less people using namespaces for real workloads. Next slide, please. So another kind of benefit, we were talking about how certain things are synced and you can sync things both ways from the host to the vCluster as well. So when you set up multiple physical clusters, you have all these workloads that you typically install on each and every one. You have to manage those. They cost money. They're using CPU and memory. It's harder to update them and so forth. Next slide. So what you can do is you can move these individual physical clusters to vClusters, and then go ahead and go to the next slide, and I'll just show kind of like what it looks like in an end solution. Now you're able to share a lot of these things because, like, for example, with Istio, or in the case in our demo today, we're using Ingress and Nginx. You can run the controller for those things just on the host, but then sync the necessary resources like the Ingress resource. In my demo today, the only thing that we're actually syncing besides the pods and secrets and config maps is storage is Ingress resources, so that we can leverage the Ingress controller that's running on the host cluster. Next slide, please. So again, the takeaway is that vClusters are fully certified Kubernetes distributions. You can deploy everything to a vCluster just like you would a physical cluster, and you can give full autonomy to whatever teams that need access to a full-fledged Kubernetes cluster. Next slide. Okay, demo. So this is where I'm going to take over the screen, and I'm going to do a live demo. So hopefully the demo gods are with me today. But basically, let's see. Do I just take it away from
Yeah,
here?
I think, Kurt, before we get into the demo and, till by the time you figure out the screen and your demo, I think we have a few comments coming in. So, a couple of highs. So hi, Pradeep from Pune. Hi, Sai, who is joining in from Kolkata. And hi, Rahul from Bihar. Thanks for joining in. So, Kurt, I think we have a question from David, and I guess we can answer that. I'm just putting it up on the screen. So David asks, can a virtual cluster host provide a sub-virtual cluster?
Oh shoot, 1 second. I'm gonna have to quit and reopen. I thought this was working yesterday when we went through the dry run, but I'm not able to share my screen. So let me just quit and reopen. I'll be right back, okay?
Okay, sure. So I think while we wait for Kurt to come back with his demo, the demo gods apparently don't seem to be in a good mood today. We David will take your question once Kurt is back. So
I
until
think
now
technically
we
it is possible to have a sub-virtual
yeah
cluster. You could do Inception, like I think as many levels as you want.
Inception.
But I'm just thinking, what will be the implications in terms of, I don't know, like performance and other aspects basically.
Yeah, I think this is something we probably all have to give it a shot. I mean, theoretically, like Vishal said, this might be possible, but then practically, at least I have to try to give an answer. Maybe Kurt might have tried it in some way or the other.
Yeah, actually, the demo today, like we were using Argo CD and vCluster Pro, the control plane that has a UI and a controller. All that's actually running in vClusters, and then we're spinning up vClusters inside of that environment. So yes, you can actually run vClusters inside of vClusters. At the end of the day, though, the things that get synced to the host gets, there's no levels for that. They're being synced to the host, the same host that everything else is running on, unless you're using vCluster Pro and using multiple clusters that are connected. So, okay, let me just set the stage for the demo here. We were talking about developer productivity. So the use case that I'm going to kind of walk through today is using vClusters for ephemeral demo environments for GitHub pull requests. Basically, we'll spin up ephemeral demo environment by adding a label to a pull request that will then create a vCluster using the Loft CLI. And then it'll actually we'll use a GitHub Actions workflow to use that CLI, and then we'll add an additional label once the vCluster is up and running to send a webhook to add another label that will trigger a webhook to Argo CD. We're using the application set with the pull request generator, so that'll automatically create an application for this pull request in Argo. Also, we're leveraging virtual cluster templates with vCluster Pro, which we'll take a quick look at and show how we've integrated Argo CD so that when that vCluster is created, it's automatically added to Argo CD as a potential target for applications, in this case, the pull request. So let me go ahead and click on the pull request. And the first thing I'm going to do here is I'm going to add a label. All right. So basically, I've got this preview label. As you can see, I've done it a few times back and forth. So I'm going to add that preview label. And once I add that, that should trigger a GitHub action workflow over here. This create PR preview. So I'm going to click into that. And then as this kicks off, I'm actually going to take a look at the workflow file and just walk you through what's going on here. So first, you can see that we're doing this on pull requests and for different labels. But then we're actually setting up down here on line 26, we're setting up the Loft CLI. In the CLI, we're logging into our control plane, our vCluster Pro control plane here at the vCluster demo URL. And we'll take a look at that eventually once this is up and running. We provide an access key that we got from that environment. In addition to the CLI, this GitHub action also installs kubectl if you're not using an agent that already has it installed. Then we're using that CLI to create a vCluster. And some of the kind of unique, there's also a vCluster CLI. I'm specifically using the Loft one to be able to log directly into the cluster. And that's why I'm using the Loft one today. But you could do something similar with the vCluster. You can see something unique that's not available with open source is this concept of a project. I'm creating this in a vCluster Pro project, and I'm also using this preview template. And we'll take a deeper look at templates. In addition to that, I'm also in the UI, you can see a list of vClusters in vCluster Pro projects. I'm adding these additional links that are related to this pull request. So I'm adding a link, and these will show up as links in vCluster Pro user interface. So I have a link back to this pull request that kicked off this job. I have a link to a simple preview environment. The whole reason we're using this, just a very simple application in this case, just for demo purposes. And finally, there's a link to look at the deployment in Argo CD from the vCluster Pro UI. Then once this is done running, then basically vCluster's up and running once this command completes. I'm adding a label to the pull request that will actually trigger the application set. So I've set up a pull request generator that's listening for this previews cluster ready, and then that'll trigger the application set to generate an application in Argo CD. And then finally, I'm just updating the pull request with some links, so that it's nice to have links so that developers can work in whatever context they're most comfortable in. So I have links in Argo CD, I have links in vCluster Pro, and then I have links in the actual pull request itself as well. So it looks like our job has completed. Let me see if I can get my mouse here. So I'm going to go back to the pull request and click on it, and we should see at the bottom here, now we have some links. And so this link here, my mouse is freezing up. Apologies, I don't think my machine likes Chrome. So I'm going to click on this link here, and that's going to take me to the vCluster Pro user interface. So I'm going to sign in with, actually, let me just switch to this guy and see if it's any better. Nope, still a bit glitchy. Here you can see that, apologize, my mouse is glitching. The demo is working, but the computer's not being responsive. Whoop. Okay, here we go. So here we can, that's the vCluster that was just created, and we can actually take a look at the pods, and here is our application pod that's running. And within vCluster Pro, we can actually look at the logs for those pods. Also, if I go back up to the list of vClusters, you'll notice that, if I close the logs here. Okay, that was not. You can notice that I have other vClusters that are actually sleeping. So that's another feature of vCluster Pro, where after a certain amount of inactivity, the vCluster Pro controller will automatically put the vCluster control plane and all the workload pods to sleep. That is, scale all the pods down to 0, thus reducing cost. So you might have a preview environment, use it during the day, leave it running, go home. That just shuts everything down, so you're not incurring costs when people aren't actually using them. Also, you notice here that we're using a template for all these, and we're going to take a quick look at that template. So let's dive into that template. One thing you'll notice right away is this pop out of this YAML. Everything in the UI of vCluster Pro is backed by custom resource definition, including these templates here. So it makes it very easy to manage this platform with GitOps. You'll notice at the top level, we have the ability to configure our vClusters the way we want for all the preview environments. So we can decide which distribution we want, which version of the Helm chart we want, and then the values. I mentioned earlier that, some things have to be synced from the vCluster to the host cluster, but other things, it's up to you. And so I mentioned that I wanted to sync ingresses to provide an ingress for different services that run as part of this preview environment. So I'm syncing ingresses. Also, I'm enabled isolation. And core DNS is integrated to streamline the size of the pod. So I don't have an extra pod for core DNS. It's actually integrated into the vCluster pod itself. Also, I mentioned sleep mode. Basically, sleep mode allows you to specify a certain amount of time of inactivity, meaning no Kubernetes API interaction with the vCluster, or also works with Ingress Nginx, so no ingress activity. And then after that amount of time has gone by, then the vCluster will be put to sleep. That is, it'll reduce all the pods to 0. And in addition to that,
but can we make the screen slightly bigger? I think there is the window
sure.
is like smaller than the entire screen.
Yeah.
No, what I meant was, yeah, that's better. Thank you so much.
Yeah, let me make it a little bit smaller. Can everybody see that? Okay.
Yeah, perfect.
Another feature of templates is adding arbitrary Kubernetes objects and apps. I'm not going to go deep into apps, but basically that's a Helm chart or Kubernetes manifest. But the objects in this case, I'm actually injecting a secret, a pull request secret, to pull the images from a GitHub container registry, a private one. And actually, this is a bogus secret. I'm actually leveraging a feature of the platform called project secrets, where all you have to do is include a label that specifies a project secret. And then when this instance is created from this template, it'll dynamically pull in that, generate that secret, and make it available inside of that vCluster. Also, I just wanted to jump through some of these advanced options, not all of them, only the ones that we're actually using for this preview environment. One of them is ingress authentication that works with Ingress Nginx. It allows you to specify that authentication must happen through the vCluster Pro SSO to interact with any of the ingresses that are created as part of this vCluster instance. So that's nice, especially like in GitHub, if other people have access to the pull request, but you don't necessarily want them to have access to the preview environment. That's kind of a really slick feature. Also, Argo CD, we mentioned that. At the project level, we integrate with Argo CD, but then now also at these templates, you can say, hey, for this particular virtual cluster template, just go ahead and automatically add the vClusters to Argo CD so I don't have to do it manually. And so that makes them instantly available as targets for applications in Argo CD. And it works really well with this concept of preview environments because it's no extra steps to basically make that vCluster available for the deployment for that pull request. So I'm going to go back to my list of vClusters. And here you can see it's running. So here's the links I mentioned before. Also, you notice up in the top right, we have a link to Argo CD. I'm going to go ahead and link to Argo CD from this link here, and that will take me into the application. So here is our simple little application that's running. We can change the view, but you can see that it's been synced and running, and it's running on this particular vCluster. If I look at the details and look at the cluster that it's running, we can see, sure enough, it's running on that vCluster that I just created. So I'm going to go ahead and close this. And then now what I'm going to do is I'm actually going to use these links. I'm going to go back to my GitHub pull request. Actually, I'm going to be logged in. I'm going to bring in my other screen for that, actually. Because I'm not logged into the GitHub over there. So let's go back to our GitHub pull request. And we are going to go ahead and actually merge it. We looked at the preview environment and everything looked good. And so we're going to go ahead and merge that pull request. You can confirm merge. And upon merging that pull request, well, I guess it's also good practice usually to delete the branch if you're done with the feature branch. So yep, now it's going into production. We have another action that's listening for either the label removal or for closing the pull request. And that is going to delete, remove the label for the preview environment and then delete the vCluster. And if we go back and look at our environment, we can see that our vCluster is already terminating. And then if we go over to Argo CD, we'll see that, again, also another integration is single sign-on between vCluster Pro and Argo CD. And we'll see here in Argo CD that our application is gone. Pull request 8 no longer here. Everything's cleaned up, and we can go about our business and start working on our next feature. So that wraps up the demo. Apologize for the little bit of lag there with my mouse. But that's it for me. Thank you.
Great. Thanks a lot, Kurt. I think the demo perfectly summed up the discussion that we had, talking about consistency and templating. And I think vClusters actually showed how it works and how we were able to achieve the whole ephemeral setup. And the entire workflow that you showed, it looks perfect for anyone who wants to build preview environments. For example, I come from a testing background. I've been a tester for a long time. So I think this, for me, looking from a testing lens, I think it looks really good way to bring up environments. At, let's say, at probably if I want to perform integration testing. So once I have my test in place, we can set up the pipeline to bring up the virtual cluster, run the tests, gather the results, and then probably destroy the cluster that we have. So I think the entire demo did show how these things actually work and the benefits that brings. So I think that just erodes the problems that we had, the small hiccups we had in the demo. I think the output that we got is way much bigger than those small hiccups. So thank you so much, Kurt, again for the wonderful and insightful demo. I'm sure everyone who had seen, including me, I'm definitely going to go back and give this a try because demos are always inspiring for all of us. When we see something happening, see something running, at least I always feel that I should go back and probably try it and try it myself and see how that works. So thanks once again for being here and for the demo. And quickly to sum things up, what we discussed, we started this webinar discussing about virtual clusters, and we touched upon the most fundamental basics as to why they are called virtual clusters, because they are virtual clusters, like Vishal rightly mentioned. And then we took a little bit of detour to understand how virtual clusters actually help developers, into their regular workflows. You talk about agility that they bring, the ability to identify bugs faster, because the entire process speeds up now. We also looked at the future aspects, the challenges and opportunities with respect to virtual clusters, especially in the day when we talk about multi-cluster setups and hybrid environment. And we finally summed it up with this wonderful demo that actually showed how we can, use vClusters to set up ephemeral and preview environments. So I think, with that, I will just quickly go through the comments for any further questions that we might have. So I think we had David who had asked, so we did answer his query, and I don't see anything else at the moment. And I think that basically justifies, or rather answers, the wonderful demo that we had. So whatever discussions we had, we immediately had a wonderful demo that complemented it. So I guess everyone who saw the demo have a good understanding about what we spoke about, around virtual environments, virtual clusters, so on and so forth. So that's it. I think before I close, any few final thoughts, Kurt, that you would like to add on the topic or on the webinar in general.
Yeah, I just wanted to mention one other thing. I was a little flustered with the mouse being flickery, but one other kind of cool feature of vCluster in these kind of ephemeral environments is the ability to run different versions of Kubernetes than what the host cluster is running for different tests. And in addition to that, like different versions of the operators and controllers and CRDs, you can run all those within a vCluster without actually spinning up a full physical cluster. So it really, really lends itself to developer testing.
Absolutely. I think I see it as a very good way for regression testing, multiple versions of the environment, of the infra that we need. You can quickly set it up. Like you said, it supports different versions. So it definitely, helps us with that. Vishal, any final thoughts from you on the whole topic of environments and virtual clusters?
Sure. I just want to tie this back to the platform engineering, the core topic, that we were talking about. I
Yeah.
think if you want to enable developers with different versions and various varieties of new clusters, in a short window of spinning up things, I think vCluster is a great technology. Enables virtual clusters seamlessly, and I think that's a great enabler for building a platform which really helps developers move faster.
Absolutely, absolutely, and that is why uh, vClusters is one of the tools that we have suggested in the ebook that we have published. So once again, if you want to get started with your platform engineering journey, or if you are having any issues where you don't know where to go or how to go about it, get this ebook. You can scan the QR code to get the ebook and get your journey started. Also, do give vCluster a try. vCluster.com is where you can go ahead and try your hands on vCluster. And Kurt is definitely around on LinkedIn, so do hit him up if you have any issues while using it, or if you need any help. And yeah, so thank you so much, Kurt, for joining in and for sparing the time with us and the audience, and enlightening them with your expertise. Thank you so much, Vishal, again, for the time, and again for this beautiful discussion. And also a big thank you to all the members who have joined in from LinkedIn and all the other platforms. This was the second webinar that we did. If you have not seen the previous one, we did share the QR code so you can go through the playlist that we have. And we will be coming again with another webinar soon. So please keep an eye on our social media channels and be sure to subscribe to those updates as well. So until then, have a good day, good evening, wherever you are, and have a wonderful time. Thank you again. Bye bye.
Thank you. Bye bye.